Hello everyone, this is Usha from Department of Computer Science and Engineering. Today I am going to explain about the topic topological sorting in advanced algorithms. What is a topological sorting? Topological sorting for a directed acyclic graph is a linear ordering of vertices such that for every directed edge UV, the vertices U comes before V in the ordering. So, here what is the directed acyclic graph? For example, if you consider the graph like this, here these are the vertices A, B, C, D. These are the vertices, and also it is a directed graph. Here, this graph is a acyclic graph since there is no cycle in this graph. Example of a cycle graph: A, B, C, D. Here A, B, C, D are the vertices. This is a directed graph, but it is a cycle graph. So, the topological sorting for a cyclic graph, directed cyclic graph is not possible, whereas the topological sorting for a directed acyclic graph is possible. For this, the topological sorting is not possible. For example, if you consider the above graph, here 0, 1, 2, 3, 4, 5 are the vertices, and also this graph is a directed graph and acyclic graph. So, the topological sorting for this directed acyclic graph is possible. The first vertex in the topological sorting is always a vertex with an integrity of 0. What is the integrity? Here, the number of incoming edges to a vertex is nothing but a integrity. For example, if we consider the vertex 5, the integrity of 5 is 0. Similarly, for 4 is 0. For vertex 0, the incoming edges are 2. So, the integrity is here 2. For vertex 1, the integrity is 2. For the vertex 3, the integrity is 1. And for the vertex 2, the integrity is 1. So, in the topological sorting, the first vertex is always with a integrity of 0. Here the topological sorting, either it starts with the vertex 5 or the vertex 4. One of the topological sorting of the above graph is 5, 4, 2, 3, 1, 0. There can be more than one topological sorting for a single graph. Another topological sorting of the above graph is 4, 5, 2, 3, 1, 0. Here the basic idea is nothing but if you consider a directed edge 1, 2. According to the definition of a topological ordering, the vertex U should always comes before in the ordering of the topological sorting. Here, the vertex 1 always should come before 2. This is the basic idea of the topological ordering. Another example, if we take 4, 5. So, the vertex 4 should always come before the vertex 5 in the topological ordering. And also, the vertex 5 should always come before the vertex 6 in the topological ordering. Here is a step-by-step algorithm for topological sorting using depth-first search. First step is nothing but create a graph with n vertices and m directed edges. Initialize a stack and a visited array of size n. First we have to initialize a stack and also a visited array of size n. For each unvisited vertex in the graph, we have to do the following steps. Call the DFS function with the vertex as the parameter. So here, in order to find the topological sorting of any graph, we are using the depth first search process. So first step is nothing but call the DFS function with the vertex as the parameter. Then in the DFS function, mark the vertex as the visited vertex and recursively call the DFS function for all its unvisited vertices. Once all the neighbors have been visited, push the vertex into the stack. After all vertices has been visited, pop elements from the stack and append them to the output list until the stack is empty. The resulting list is the topological sorting order of the graph. I will explain you with the example. So here, this is the graph. Here all the edges are directed and there is no cycle in this graph. So it is a directed acyclic graph. Now we are going to find the topological sorting for this graph. According to algorithm, we are creating one stack and a visited array. So according to DFS, depth first search, what the algorithm says, we have to call the DFS function. First step is we have to call the DFS function with the vertex as a parameter. Now for example, I am taking the vertex D. I am starting from vertex D. So we have to mark the vertex D as visited vertex in the visited array. We have to explore all its neighbors according to the depth first search process. So what are the neighbors of D? Here the vertex F is the neighbor, only neighbor of vertex D. So I am marking the vertex F as visited. Since there are no more neighbors of D, we have to explore from F now. What is the neighbor of F? The vertex G. So I am marking the vertex G as visited array. G in the visited array. Is there any neighbors for the vertex G? No. So the algorithm will roll back to, Is there any vertex neighboring to the vertex G? No. So the vertex G is pushed into the stack. So the algorithm roll back to vertex F. Since there are no more neighboring vertices of F, the vertex F should also be pushed into the stack. Now roll back to vertex D. Since there are no more unvisited vertices of vertex D, so we have to push the vertex D also into the stack. Now consider the vertex B. Consider the vertex B. What are the neighboring vertices of vertex B, C and E? First of all, I have to mark the vertex B as visited. The neighboring vertex of vertex B are C and E. So I am going with the vertex C first, marking the vertex C as visited. Explore the neighboring vertices of C now. The only neighbor of vertex C is D. So D is already in the visited list. So roll back to vertex B. The other neighbor of vertex B is E. So I am marking that vertex E as visited vertex. So what is the neighbor of E? We have to explore the neighbors of E now. What is the neighbor of E now? F. F is already in the visited list. Roll back to vertex B. Since C is already visited, we have to push the vertex C into the stack. Now the vertex E also should be pushed back into the stack, and also the vertex B. What is the remaining vertex? The vertex A. Mark the vertex A also in the visited array and push the vertex A into the stack. According to the algorithm, after the stack is full, then pop out the elements one by one. A, B, E, C, D, F, Z. This is the topological sorting order of this graph. You can see here, C is the dependent of A and B. C is the dependent of A and B. So, the order A, B should come first, and then the vertex C will come. Like that, this is one of the topological sorting order using DFS, depth first search. What are the applications of the topological ordering? Topological ordering can be used in the task scheduling, software dependency resolution, building makefiles, compiler optimizations, dependency analysis, deadlock detection, course scheduling, etc. So, this is all about the topological sorting. Thank you.